Hello everybody, this is our video number 3 on the same topic and the limit and the derivatives. And in this video, we will start our discussion on the topic the derivatives. So this is the definition of the derivatives, and it is written as this form, and this is read as the ddx of fx. It is equal to f dash x. And it is nothing but the derivatives of this fx with respect to x. Okay, and this fx is nothing but a function, and we already know that any function fx is represented as this form, that means y. So with the help of this form can be written in this form, the dy dx. Okay, and this form is written as the y dash or y1. Okay, so if you consider the definition of the derivatives, the two variables are involved. The first one is y and the second one is x, and the derivatives of y is with respect to x. That means the small change of y is major the small changes of x. That is the main fundamental concept of the derivatives. So another definitions of the derivatives is the limit x tends to 0 f x plus h minus fx by h, and another one is the limit x tends to 0 and f a plus h minus fx by h. The second form is another form is the first, and this form is called the first principle of the derivative. The first principle of the derivatives. Okay, and these are some predefined derivatives or the common derivatives. The derivatives of x with respect to x is equal to 1. Derivative of x to the power n, and n is nothing any integers. That means the n into x to the power n minus 1, and derivative of e to the power x is produced e to the power x. So, and derivative of any constant with respect to x, it is produced the 0. These are some predefined derivatives. So with the help of all this formula and the concept of the derivative, we will solve some problem from our exercise 13.2 from your NCERT. So exercise 13.2, consider the question number 1. Question is, find the derivative of x square minus 2. So that means that fx is equal to x square minus 2 at x equal to 10. We can process or we can find the derivative in two ways. The first, using this formula at x equal to 10. So when the value of x is defined, or the derivative, find the value of the derivative as particular certain point, then we use this form of the first principle. Okay, so we can find the derivative of this function in two ways. The first, using the first principle, and the second one using this method. That means using the predefined derivatives of the common derivatives formula. So at first, this fx, so limit x tends to 0 f of, what is the value for this a? This is the find out the derivative when x equal to a, and this time the value of a is 10. That means the 10 plus h minus f of 10 by h, and it is equal to f dash 10. That means that find out the derivative of this function when x equal to 10. Okay, so from this we can write the limit h tends to 0, and this time write the 10 plus h whole square minus 2 and minus f of 10. F of 10, what is the value of the f of 10? That means the 10 square 198, okay, by h. From this, the limit h tends to 0, hundred plus 28 plus h square minus 2 minus 98 by 8. Okay, after that the limit h tends to 0, the 100 plus 28 plus h square minus 2 minus 98 by h. This 100, this 2, this 98 cancels. That means after performing the cancellation, the limit h tends to 0, 28 plus h square by h. After that, the limit h tends to 0, 20 plus h. After putting the value in place of h is equal to 0, it is putting the 20. So the derivative of this function at x equal to 10 point is 20. So this is our first process using the first principle, and the second one fx is equal to x square minus 2, and the derivative is written as the derivative with respect to x ddx of fx is equal to the derivative of x to the power 2 x square minus 2. Okay, and from this we can write the split this derivative, the derivatives of x square minus the derivative of this 2. This is the one of the property of this derivative. When the any function is connected to the addition subtraction, or the many terms of the connected to the addition and subtraction, then we split and performing the individual derivatives for each term. After that, using this formula, the derivative of x to the power n is equal to n into x to the power n minus 1. So that means it is the 2 into x to the power 2 minus 1, and the derivative of any constant is always produce 0. That means the 2x. So the derivatives of fx is equal to 2x. So what is the value at x equal to 10? That means the derivatives of fx at x equal to 10, it is produced 2 into 10 is equal to 20. The same value. It is produced the same value, but solving procedure is different. The first one we use the first principle of the derivative, and the second one we use the common derivatives or the predefined derivatives, and we reach the same destinations or we get the same value for this particular derivatives at the particular points. Next, 7.1. Question number 7.1. fx is equal to x minus a into x minus b, and this time this a and b are constant. Okay, so how to solve this problem? So first of all, before we go into the process of this problem, one important formula of the derivatives. The derivatives of u into v is u into the derivatives of v plus v into the derivatives u. This formula in derivative is called the product formula. The product formula, that means that when the two function is in form of the product, then we apply this formula. That means if you consider this one is our first function and this one is our the second function, that means the formula is the first function into the derivative of the second function plus second function into derivative of the first function. So for this problem we will use this particular formula, because if you consider this fx contains the two different function, and consider that this one is our first function, that is the u, and this is the v. That means the derivatives differentiating with respect to x. That means derivatives of fx is equal to the x minus a derivatives of the second function x minus b plus the second function derivatives of the first one. After that, the x minus a, and the derivative of x is always 1 and the derivatives of b is 0. That means 1 minus 0 plus x minus b, and this time it will also produce the 1 minus 0, because the derivative of this x is 1 and the derivative of any constant is produced as 0. So that means x minus a plus x minus b, and this is 2x minus a minus b. This is the derivative of this function with respect to x. Okay? Next one, 7.3. fx is equal to x minus a by x minus b, and this time we use the another important formula of the derivatives, that is the dx of u by v is nothing but the v square v into derivatives of u minus u into the derivatives of v, and this time this is the form of the division. The two function is in form of the fraction or the division, and this time it is denoted the first function and this is our second function, and the formula is the second function into the derivative of the first function minus first function into the derivative of the second function whole divided by the whole square of the second function. So for solve this problem we use this formula. Differentiating with respect to x. Okay, so that means the dx of fx is nothing but this is our second function, it is b, and this is u. That means x minus b whole square, and x minus b into the derivative of the first function is 1 minus 0, and minus the derivative, the first function x minus a into the derivative of the second function. This is also produced, and this time it is x minus b minus x minus a by x minus b whole square, and from this it is x minus b minus x plus a by x minus b whole square, and this time this x and this x is cancelled, and the final result is a minus b by x minus b whole square. Okay? Next, 11.1. Let y is equal to the given function is sin x into cos x. So after performing the derivative, differentiating with respect to x. Okay, so that means dy dx is equal to, apply the products rules. Okay, so that means sin x derivative of cos x plus cos x derivatives of sin x. So that means the sin x and derivative of cos x is the minus sin x. Cos x derivative of sin x is equal to cos x. That means cos square x minus sin square x, and it is nothing but the cos 2x. Okay, so that's all for the today's lectures. Thank you everybody.